There are reports of extraterrestrial life forms referred to as outcasts, suggesting they originated from beyond Earth. NASA, well known for its groundbreaking discoveries, has recently unveiled a planet that's not only intriguing because of its size and location but also because it exhibits lights that seem artificial. Could these lights be a clue to life on other planets? Is this discovery on the verge of reshaping our understanding of the universe? Join us as we delve into NASA's captivating findings and explore the truth behind these mysterious lights. In 2007, NASA launched the Dawn spacecraft on a mission to explore some of the most fascinating objects in our solar system. Dawn was equipped with 3 ion engines, which allowed it to undertake an extraordinary journey. The mission began with a 14-month investigation of Vesta, the second-largest object in the asteroid belt. During this time, Dawn sent back detailed images and data, revealing Vesta's complex surface and geological history. Once its primary mission at Vesta was complete, Dawn embarked on the next and arguably most exciting part of its journey, a close study of the dwarf planet Ceres. Thanks to its ion engines, Dawn could leave Vesta's orbit and set off for Ceres, a feat that would have been challenging with conventional chemical propulsion. These engines provided a gentle yet continuous thrust, enabling Dawn to cover vast distances and eventually achieve a stable orbit around Ceres. Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi, is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest known dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most captivating due to its unusual features. As Dawn approached Ceres, scientists eagerly awaited the first detailed images of this enigmatic world. What they saw were bright spots scattered across its surface, especially prominent within a large crater now known as a crater. These bright spots sparked immediate curiosity and speculation within the scientific community. Before Dawn's mission, the best images we had of Ceres were low-resolution, blurry photographs taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the possibility of finally getting a close-up view was thrilling. What mysteries would Ceres unveil? What new discoveries awaited? Dawn promised to enhance our understanding of the solar system's evolution and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water, raising the intriguing possibility of cryovolcanism, where volcanoes erupt with water or briny liquid rather than molten rock. But what exactly were these mysterious lights? And what did they reveal about the nature of Ceres? Could they be evidence of ongoing geological activity, or were they something even more extraordinary? Ceres stands out from other celestial bodies in the asteroid belt due to its size, mass, unique composition, and potential for water and ice. Unlike typical rocky asteroids, Ceres has a structure more similar to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years of travel, the Dawn spacecraft finally reached Ceres in early 2015. This marked a major milestone in the mission, as Dawn was ready to provide humanity's first close-up views of the largest object in the asteroid belt. As dawn neared, the images of Ceres grew increasingly detailed, offering tantalizing glimpses of a world that had been shrouded in mystery for centuries. The initial pictures revealed a cratered surface, evidence of a long history of impacts. However, it wasn't just the craters that captured the attention of scientists and space enthusiasts alike. Among these features were peculiar bright spots that stood out sharply against the darker, rocky terrain. As the images continued to improve in resolution, mainstream scientists buzzed with speculation about the nature of these bright spots. Were they patches of ice reflecting sunlight, or could they be something much more exotic? Theories ranged from mineral deposits to potential signs of cryovolcanic activity. Closer analysis revealed that the brightest spot wasn't a single entity but rather a collection of several distinct spots. This discovery only deepened the mystery, with a prevailing theory suggesting that these were deposits of salts left behind by sublimating water. Additional evidence of surface distortion on Ceres comes from the observation of cracks, grooves, and ridges across its terrain. These features demonstrate that the crust of Ceres has undergone immense pressure and deformation. Some of these cracks appear relatively young, possibly just a few 100 million years old, indicating that the surface may still be somewhat active. Grooves and ridges likely formed as the crust stretched and pulled apart, while mountain ranges and compressional ridges highlight areas where the surface was pushed together. These contrasting features provide a glimpse into the complex processes that have shaped Ceres over time. One of the most intriguing findings is a large dome-shaped mountain in one of Ceres' craters, which suggests internal pressure or material upwelling, possibly related to cryovolcanism. This feature, along with the extensive network of cracks and ridges, points to a dynamic and evolving surface. NASA's Dawn mission has also revealed fascinating surface compositions beyond the bright spots and reflective salts. Data has uncovered a range of materials critical to understanding the history of Ceres. For instance, some areas on Ceres show a dark, fine-grained material that sharply contrasts with the brighter salt deposits. This darker substance is believed to be carbon-rich, possibly organic in nature, adding another layer of complexity to Ceres' composition and hinting at the potential for prebiotic chemistry. The connection between these materials and the icy surface may play a role in the chemical processes occurring on Ceres. Moreover, the discovery of organic compounds on Ceres has sparked significant interest in astrobiology. These carbon-rich molecules, the building blocks of life, suggest that Ceres might have once harbored conditions suitable for the formation of more complex organic structures. The presence of these compounds raises exciting possibilities about the potential for life, or at least the foundational components of life on this dwarf planet. Another notable feature on Ceres is the numerous dome-shaped structures scattered across its surface. Some of these domes reach heights of up to 6 kilometers and are thought to result from subsurface processes pushing material through the crust. Their shapes and sizes suggest they may have formed from cryovolcanic activity or internal pressure forcing materials upward. Understanding these structures is essential for piecing together Ceres' geological history and its internal composition. In addition, gravity data gathered by the Dawn mission has provided insights into the internal density distribution of Ceres. Variations in gravity suggest the presence of different layers within the dwarf planet, indicating that Ceres may have a complex internal structure, possibly including a subsurface ocean or briny pockets. These findings are crucial for understanding Ceres' thermal history and its potential to support life-sustaining conditions. Overall, the Dawn mission has not only expanded our knowledge of Ceres but has also transformed our understanding of small celestial bodies in the solar system. As more data is analyzed, scientists hope to unravel the mysteries of this fascinating world and its ability to shed light on broader processes governing planetary formation and evolution. Adding to the intrigue, there have been sensational claims about off-world beings, with some speculating that NASA's findings on Ceres point to artificial lights. In recent years, NASA has revealed that this dwarf planet is remarkable not just for its size and location but also for the peculiar lights observed on its surface, which some believe could be artificial. Could this discovery indicate the presence of extraterrestrial life? Join us as we explore NASA's captivating findings and uncover the truth behind these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with a mission of exploring some of the most intriguing objects in our solar system. Equipped with 3 ion engines, Dawn embarked on an unprecedented journey. Its mission began with a 14-month study of Vesta, the second-largest asteroid in the asteroid belt. During this time, Dawn sent back detailed images and data, revealing Vesta's complex surface and varied geological history. After completing its primary mission at Vesta, Dawn embarked on the second, and perhaps most exciting phase of its mission, a detailed investigation of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and set course for Ceres, a feat that conventional chemical propulsion would have struggled with. The ion engines provided continuous, gentle thrust, allowing Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, It was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most fascinating due to its unique characteristics. As dawn approached Ceres, scientists eagerly anticipated the first detailed images of this enigmatic world. They observed bright spots scattered across its surface, most notably within a large crater now known as a crater. These bright spots sparked immediate interest and speculation among scientists and the general public. Before dawn's mission, the best image of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Little was known about this dwarf planet, and the prospect of finally getting a close-up view was exhilarating. What secrets would Ceres reveal? What new insights awaited the mission? Dawn promised to enhance our understanding of the solar system's evolution and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water, leading to the hypothesis of cryovolcanism, a process in which volcanoes erupt with water or briny fluids instead of molten rock. But what exactly are these mysterious lights? And what do they reveal about Ceres? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres stands out from other celestial bodies in the asteroid belt due to its size, mass, unique composition, and potential for water and ice. Unlike typical rocky asteroids, Ceres has a composition more similar to a comet, suggesting it holds more secrets about the early solar system than previously thought. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015. This milestone marked a significant achievement in the mission, as Dawn was poised to provide humanity's first close-up views of the largest object in the asteroid belt. As dawn drew closer, the images of Ceres became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The initial images revealed a surface dotted with craters, indicative of a long history of impacts. However, it wasn't just the craters that captured the attention of scientists and space enthusiasts. Among Water
these
accumulation
were
on
unusual
Ceres
bright
suggests
spots
that the dwarf planet has experienced
with the
or
darker,
still has some
rocky
form of topographical activity capable of transporting water or briny liquids to the surface. These materials would rapidly dissipate, leaving behind brilliant, reflective salt deposits. These findings challenge previous assumptions about Ceres and reveal a more complex and dynamic world than initially thought. The presence of such elements hints at the possibility of subsurface water or briny pockets, which could have significant implications for the potential of life within our solar system. What sets Ceres apart from other planets and celestial bodies is its unique composition. Often described as a cold world with a rugged yet porous surface, Ceres differs from most asteroids in the belt, which are primarily composed of rock and metal. Its surface is a mixture of water, ice, and hydrated minerals, including clays and carbonates, giving it a less dense structure compared to its neighbors. This composition suggests that Ceres holds large amounts of water. Its icy surface is rough but porous, trapping ice and other volatile compounds. This characteristic is more reminiscent of a comet than a typical asteroid, indicating a history that likely involved a mix of rocky and icy materials. Beneath its surface, Ceres reveals even more intriguing features. The dwarf planet is believed to have a layered interior, with a muddy mantle and core. The mantle, thought to be rich in water ice, accounts for around 50% of Ceres' total volume. This mantle may be a combination of rock and salty water, surrounding a denser core, possibly made of silicate materials. The abundance of water ice suggests that Ceres may have once harbored liquid water, especially if its core was heated by radioactive decay in its early history. This internal structure sets Ceres apart from its asteroid neighbors and raises fascinating questions about its geological activity and the role water played in its development. Moreover, the discovery of ammonium-rich clays on Ceres implies that the dwarf planet may have formed in the outer reaches of the solar system before migrating inward. Ammonium can lower the freezing point of water, supporting the presence of subsurface brines. These insights into Ceres' composition and history not only deepen our understanding of this intriguing dwarf planet, but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism, a fascinating and relatively rare geological process, plays a key role in shaping Ceres' surface. Unlike conventional volcanoes, which emit molten rock, cryovolcanoes, also known as ice volcanoes, release volatiles like water, ammonia, or methane. These substances can exist as liquids or gases in the cold environments where cryovolcanoes are found. On Ceres, cryovolcanoes allow water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it quickly sublimates, transforming directly from a solid or liquid state into gas. This process leaves behind brilliant salt deposits, which form the mysterious bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, often referred to as Spot 5. This area has garnered significant attention due to its high reflectivity and the occasional mist observed by the Dawn spacecraft. These mists are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. In addition to Spot 5, Ceres has several other bright spots, each with unique properties. These spots are not confined to a single region but are distributed across the dwarf planet's surface, indicating that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots underscores the dynamic nature of Ceres and raises important questions about the potential for life in our solar system. The active and changing surface of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features emerged, including various craters that tell the story of the dwarf planet's history. Some craters are shallow and eroded, indicating an older surface that has been subjected to numerous impacts over billions of years. Others are better preserved, with sharp rims and deep bowls, suggesting more recent impacts. Interestingly, the number of craters on Ceres is lower than initially expected. This discrepancy points to geological processes that may be resurfacing the planet and erasing evidence of older impacts. One hypothesis is that Ceres' icy structure allows for a type of cryovolcanic resurfacing, where subsurface materials occasionally rise to the surface, covering older features. This ongoing geological activity suggests that Ceres is not a static world but one that has been, and possibly still is, actively evolving.